welcome to the bubble sort learning module. In this unit, we're going to learn what the bubble sort algorithm is and the steps to perform the algorithm. Let's start with a given unsorted array. To sort this array, we can look at a few observations in the actual sorted array of the form. Let's say I have 6, 8, 14, 28 and 30, which will be the sorted array of this form. Consider any two adjacent elements in this array. Let's say 14 and 28. Since 14 is less than 28, 14 occurs to the left of 28. Similarly, if I consider 6 and 8, 6 is less than 8, so 6 occurs to the left of 8. By this, we can see that the relative ordering between any two adjacent elements is such that if the left element is less than the right element, then they are in the correct relative order. Let's look for the same in the given unsorted array. Let's say I consider elements 8 and 30. 8 is less than 30 and 8 occurs to the left of 30, so I can say that they are in the correct relative order. But let's say I look at something like 30 and 14. 30 is greater than 14, but 30 is occurring to the left of 14. So this is in the incorrect relative order. To correct this relative order, I can swap them. When I swap them, my array becomes 28, 6, 8, 14 and 30 because I have swapped these two elements. Let's see how we can use this to sort a given array. This was my initial given array. What I'm going to do now is consider adjacent elements at a time and see if the relative ordering is correct. I start from the first two elements. 28 is greater than 8, so the relative ordering is incorrect. So I swap these two elements. I get 8, 28, 6, 30 and 14. Then I look at the next two elements, which is 28 and 6. Again, 28 is greater than 6, so the relative ordering here is incorrect. I swap these two elements to get 8, 6, 28, 30 and 14. Next up, I look at 28 and 30. 28 is less than 30, so the relative ordering here is correct, so I need not swap these two elements. I just move to the next two elements, which is 30 and 14. 30 is greater than 14, so the relative ordering here is incorrect. So I'm going to swap these two elements and I get 8, 6, 28, 14 and 30. I've reached the end of the array with these two numbers. From here to here, I call this one iteration because I've traversed the array exactly once, looking at each pair of adjacent elements that occurred in between. If you look at this array and this array, we can see that this is relatively more sorted than the given unsorted array. In this array, a lot of the relative positionings are better than the array that I had previously. Say for example, here 30 and 14 were in the wrong relative order, but here 13 and 14 are in the correct relative order. If I keep doing this, I may arrive at a sorted array. Let's try doing it a little further. My array at this moment is 8, 6, 28, 14 and 30. Let's start the iteration again. I look at 8 and 6. The relative ordering is incorrect, so I swap them. I get 6, 8, 28, 14 and 30. Now I look at the next two elements, which is 8 and 28. Here the relative ordering is correct, so I need not swap. I can just simply move to the next elements, which is 28 and 14. Here the relative ordering is not correct, so I will have to swap them. I end up with 6, 8, 14, 28 and 30. Next elements I need to consider are 28 and 30, which are in the correct relative order, so I need not swap them. We see that here we have reached the end because we have a sorted array. Let's try to make this algorithm a little more systematic so that we can write it down and understand it. What we're doing at every point is we are comparing two adjacent elements, a of I and a of I plus 1. If I have a condition where a of I is less than or equal to a of I plus 1, I need not swap. Why? Because as we discussed, these are in the correct relative order. But if a of I is greater than a of I plus 1, I need to swap because the relative ordering is incorrect. Let's just consider another example. If say I have 3, 2, 1, 4, my 3 and 2 are in the incorrect relative order, so I will swap them to get 2, 3, 1 and 4. But if I look at these two elements, 1 and 4 are in the correct relative order, so I need not swap them.